Hello. In this video, I am going to show you how I use the program Find Orb by Bill Gray to compare astrometric observations of an asteroid that I did with other observations from other observatories, both professional and amateur. So I've made my observations and I've calculated the positions using the program Astrometrica. And what I'm going to do is open those measurements. It's the ADES format, new format. I'm going to open this PSV file. And I've got actually two asteroids in here. The one we're going to be using for this demonstration is 6259 Milioi. And here are my three measurements done in May of 2020. So I want to compare these measurements with others that were done at the same time. What I do is I go to this ASTDYS website and do a search for 6259. Here's a summary of that asteroid. What I want is the observational info. And you can see measurements were done between 1972 and 2020. I want to download this ASCII file, which will have all of those measurements. I'm just going to right-click on it, save the link as this RWO file, which is really just a text file. Now if I go in here and look at that file, here are my measurements and here are everybody else's. I'm going to open this up. It's a simple text file. Open up a notepad. Maximize this. So here are all the measurements going back to 1972. Well, I want ones done in 2020 around May. So I'm just going to scroll down here. 2020, here's January, April. So here's, May. Now, if I'm going to submit my observations to the Minor Planet Center in a timely fashion, which is a good idea, I won't have any available after mine were done, or very few. So what I'm going to do is just grab all these measurements, say from April of 2020. So I'm going to click here, and drag down and highlight all these. From April of 2020. So about there. I'm going to right click and copy those. Now, if I go back to my measurements, I'm going to open that up. Again, it's a text file. So here are my measurements that I did. I'm going to click here at the bottom. I'm just going to right click and paste those in there. So what I've got here is my measurements at the top of two asteroids in the new ADES format. All these other ones done by other observatories and amateurs in what's called the old 80 column format. Fortunately, Find Orb knows what to do with those two different formats. I'm going to save this text file. I don't know, give it a different name. Let's call it ADES report -merged. And we'll just save it. Okay. Minimize all this stuff. We'll come back to Find Orb, and we'll open that new merge file. Now, if we double click on 6259, we should see a bunch of measurements here. These were all done by others, and at the bottom, in this case, are mine. So you can see my measurements have residuals, which is really the best indicator of how accurate my measurements were compared to everybody else, these last two columns. Those are pretty good. But what we need to do is an auto solve. That actually kind of processes all the measurements and tries to come up with an orbit. So here are mine at the bottom. You see here a mean residual of 0.15 arc seconds. That's pretty big, so what we can do is remove some of the outliers. Click on this worst observation button here. It's just going to show you kind of the outliers of this data. I'm going to turn that off so that it won't be included in the measurements. And we'll just go through a few of these. Toggle the worst observations off so they won't be included. And you can kind of determine when the good time to stop is. With this process, we're getting down to 0.23 arc seconds. That's in 0.12. That's still a pretty big error compared to everybody else's. So we'll maybe do 3 or 4 more, just to see where we go. Still, there's a pretty good outlier. Okay, well, you get the idea. So now, again, the mean residual of all the observations is 0.15 arc seconds. If we do another auto solve, here we've knocked that down to 0.08 arc seconds. This is a substantial difference. Go down to my observations. Again, they haven't changed much at all, if they've changed any. 0.03, 0.02. So this shows me that my observations are pretty good compared to everybody else's. And I found myself going through this process almost every time when I was getting started in astrometry, before I submitted my measurements to the Minor Planet Center. I just wanted to make sure that I wasn't doing something terribly wrong. To make sure my measurements were reasonable before I submitted them, and this is certainly these are certainly reasonable measurements to submit. So that's about it for this video. Thank you very much for watching. I appreciate it.